So, hello, dear students. I am Dr. Shikha Pandey, Associate Professor from Institute of Aeronautical Engineering. Today, I am going to discuss about the estimation of solid waste quantity. In this lecture series of this solid waste management, as we have already discussed about the collection of solid waste and its characteristics of the solid waste and physical, chemical, and biological characteristics. And now we are going to discuss about this estimation of solid waste quantity. So the estimation of solid waste quantity is a very important part because of that only we can give idea like which which amount of storage is required, or which type of facility we should provide to keep the storage of this particular solid waste. So we are going to discuss about the waste quantification. Waste quantification refers to the quantity of solid waste generated and collected are two critical importance in determining the compliance with central and state diversion program. So the amount of total solid waste generated and the total solid waste collected are the two very important point that is related with this waste quantification. The amount of generation and the collection point quantification is is made up of two words. Two words is what? First is the very important point is that this is the waste generated, means how much amount of waste generated, and the second is the waste collection. So both of these things are connected with the waste quantification, and they are very critical importance in determining the compliance with central or state diversion program. Means what the program our government is adopting for this solid waste management in the cities. So for this one only, these two are very important. So first of all, what to select a proper equipment for the storage, or to make a proper designing of this storage of the solid waste. And so selection specific equipment is also related with the waste quantification. And this point also, this is designing of the storage, like designing of what, designing of the waste collection route, either material recovering facility, or material recovering site, or disposal facility, all are just related with this waste quantification word. Because the for the designing of the waste collection, either waste collection route, or material recovery center, or facility, or disposal facility, or like landfill site. So for all these things, this quantification plays a very important role in determining the total amount of solid waste that is generated from an area. Then only you will get idea like which method should be adopt for its either for its collection route, either for its material recovery center or facility, or for its disposal facility. And for also selecting specific equipment also, or selecting the vehicle for the hauling of the container. Then container also, means everything with this solid waste management part is related with this waste quantification. And after this waste quantification, you will get idea like in which amount we can dispose of solid waste from one place to another place, or what capacity of container should be required, what capacity of vehicle should be required for the hauling of this type of waste. So the designing of routes is also related with this quantification method. And the where is the material recovering facility, and where is the landfill site, and where is the final delivery location, where is the disposal facility, all are connected with this waste quantification. Waste quantification will reflect the total quantity of waste that is generated from any municipal site, from any household activity, or either it is from a commercial place, or it is from a residential place, whatever it is. But the quantification will reflect the total quantity of waste that is generated from any place. And this quantification will be very much helpful while designing the layout of the route of the collection routes, or while designing the storage quantity, or while designing while selecting the vehicles for this haul container system, or while making the waste collection route also, or making the material recovery facility, or material recovery site also, and disposal facilities also. So all these points are related with this waste quantification method. Waste quantification method now comes to the next point, like what it will give you idea. This waste quantification method is related with the information on the total quantity of MSW generated and the quantity of waste that is recycled or otherwise does not become part of the waste stream will be required to establish and access the performance of mandate recycling program. This will give you information on the total quantity of MSW generated and the quantity of waste that is recycled or otherwise does not become part of the waste stream will be required to establish and access the performance of mandate recycling program. This is about the total this waste quantification. Waste quantification will give you information like the total amount quantity of MSW is generated and the quantity of waste, either they can be recycled or they can does not become part of waste stream, will be required to establish and access the performance of mandate recycling program. And the MSW generation estimation of a particular either city, state or country leads to assessment of percentage recyclable. And this quantification will also give you idea like how much amount of waste can go for the recyclable practice. Like we can recycle, which amount of waste we can recycle, and it eventually enables to successfully mandate recycling programs and decide overall recycling efficiency of a particular region. So it eventually enables to successfully mandate recycling program and decide overall recycling efficiency of a particular region. Successfully mandate of recycling, mandate of recycling, and the next point is the program, and it will decide overall recycling efficiency of a particular region. It is going to be decide the overall recycling efficiency from a particular region. So this will give you idea, this will give you information. This MSW quantification will give you idea about which amount of waste we can go for the recycling process. And previously what we discussed, on the basis of waste quantification method, waste quantification will we can make the layout of the waste collection routes, we can make the material recovering facility, we can go for the disposal site also, we can select the vehicle capacity also, we can select the actual size of the container system also. So these are all connected with this waste quantification only. Waste quantification is much important in for the knowledge of the recycling material, how much amount of a recycled material will present in that particular waste. So this will give you idea about the recyclable percentage of waste. So this is a MSW, like MSW, and it is a source is there, MSW TPD is there, recyclable percentage. This will give is the recyclable percentage. How much amount this will be, this MSW total MSW is generated. And this point is red color, you can see this will give you the percentage of this much percentage of recycling you can do. So this will be like from Waste to Energy Research Technology Council has been done research, and they have given this data like the recyclable percentage of waste. So in North India, mostly 21% of the recyclable 21% of the total waste can go for the recycling purpose. Like in East India, 16% is there. Next is the South India, 17% of the total waste can go for recycling. And West India is 21%, and other cities is 19%. So you can see the waste percentage of all India. It is up to 20 or mostly 21%. Maximum is a 21%. So West India and North India is the same, and this has been study has been done to know the waste to energy conversion. Means if we know how much amount of recyclable percentage is there in a waste, we can usually make it towards the waste to energy conservation. For this one only, for many study only, this quantification is very much important. And comes to the next point. This is about the uh, this solid waste management. Why this facility, design of solid waste management facility. Next point related with the waste quantification is the designing of solid waste management facility. Waste quantification is the design of waste management facility. Waste management facility. facility. So this waste management facility. So as per the diversion and recycling of waste material increases, the quantity of waste generated, separated from recycling, collected, and ultimately required disposal in landfill become determinant in planning and designing solid waste management facility. For all the process, like from recycling to collection and then to storage and then its final disposal, means every step will require is connected with this waste quantification though. So the diversion and recycling of waste material increases, the quantity of waste generated, separated from recycling, collected, ultimately requiring disposal in landfills become determinants in planning and designing solid waste management facilities. So this point will give you idea about all the steps that is related with the solid waste management facility, like it's all designing, it's a recovery, and then it's a disposal, then it's a storage, is all connected with this quantification method only. And this quantification will give us idea about the recyclable percentage of how much amount of recyclable percentage of waste is present in a particular solid waste management, and the separation from recycling and then collected and then ultimately requiring disposal in landfill becomes a determinants in planning and designing solid waste management facility. Now comes to the next point. This is you can see this is the MSW statistics of MSW generated in different city of India. So this is the waste quantification of the MSW generated in the different city of India, and this has been given by the CPCB in the year 2002. 2000. CPCB is a central pollution control board that will give you data that will that will monitor the waste management facility, water quality, and a pollution index of any particular area. So the MSW generation estimation leads to evaluation of collection efficiency treatment facility. MSW generation or the quantification of MSW generation will leads you towards the evaluation of collection efficiency and the treatment efficiency. This will give you idea about the evaluation of collection efficiency, how much our collection efficiency is there, and next point is the treatment efficiency. So these 2 points are there. First is the collection efficiency and next is the treatment efficiency. So collected, you can see this is the data of all states of means mostly 18 states of India, from where municipal solid waste in the year 2000 and 2009 to 2011, and then collected from 2009 to 2011, and then treated MSW. So the percentage of the total waste that has been collected and which percentage of waste has been treated has been given in this data. So you can see that the percentage of its treatment is very less if we compare the both the data. Like the collection efficiency is high, but the treated solid waste is very reduced. So the percentage is very less, you can see from this data, and that's why this estimation or leads to evaluation of collection efficiency. By this data only will get idea about the efficient collection of efficiency and then treatment efficiency of solid waste generated in any city of the India. So that's why this collection and waste quantification is totally related with the efficiency of its collection or efficiency of its treatment process. Like if you know the how much quantity of waste is generated, then only you will get idea, then only you can adopt proper method for its collection or for its transportation or for its disposal from recovery site, from for final recovery site, or to up to a landfill. That's why the all the steps involved in the MSW site, like its a collection, generation, then its a storage, then its a transportation, then it's a final disposal area, final disposal, all steps is related with this waste quantification. because of this waste quantification, you can only get idea like which type of vehicle should be used, or which type of container, storage container should be used, or which type of method should be adopted for its disposal of this solid waste management. Now comes to the next point. This is about the how this volume and weight measurement should be done for this waste, for this MSW. So both volume and weight are used for the measurement. By which method? Volume and weight. Volume and weight is can be measured for this MSW management. So in a cubic yard of loose waste in different quantity from a cubic yard of waste that has been compacted in a collection vehicle. So in a cubic yard of loose waste in a different quantity from a cubic yard of waste that has been compacted in a collection vehicle, and each of these is different from cubic yard of waste that has been compacted further in a landfill. So in a cubic yard of a waste, loose waste is a different quantity from a cubic yard of waste that has been compacted in a collection vehicle, and each of these is different from the cubic yards of waste that has been compacted further in a landfill. Therefore, the measured volume of waste must be either related to degree of compaction or a specific weight. Either it is related with the degree of its total weight, or it is related with the specific waste of the waste under the condition of storage. So for this storage condition. So this is the example that is related with this volume and weight measurement, and it will reflect this cubic yard of a normal waste, loose waste in a different quantity from a cubic yard of waste that has been compacted in a collection vehicle, and each of these is different from a cubic yard of waste that has been compacted from for the further in the landfill, because in everywhere this cubic yard has been different. So therefore the measured volume of waste must be either related to the degree of compaction or the specific waste of weight of the waste under the condition of storage, because as it has been reflected with this example, because you can see that the cubic yard of in a collection vehicle is different, cubic yard compaction in a landfill is different. So the total waste volume and weight measurement of the waste is much important, so that you will get idea like in this cubic yard of the of area, how much amount of waste we can dispose. That's why this volume and weight measurement is very important. It is related with the either degree of compaction or specific weight of the waste under the condition of storage. When you are going for the storage of the waste, this degree of compaction or specific weight should be known for this condition, for the storage condition of the waste. And the representation of solid waste quantity in terms of waste is more convenience, because tonnage can be measured directly regardless of the degree of compaction. So the weight measurement of the waste is much good or much convenient as compared to the specific weight of the waste, because this total weight will represent like this much ton of waste we can store at that place. Then you can say that this much amount of waste we can dispose into the landfill site. Then this will be more comfortable as when we compare it with the specific weight of the waste. So the representation of solid waste quantity in terms of waste is more convenient. Representation of solid waste quantity in terms of the waste is more convenience, because the ton can be measured directly regardless of the degree of compaction. Tons can be measured directly when as compared to the degree of specific weight. So this volume and weight measurement of the solid waste is much important for the waste management quantification. If you will see for this waste management for this as per this specific weight, so a specific weight, you can see that in a cubic yard of the waste, if you will put some loose weight, then you have to calculate that in that landfill that much amount of waste is not applicable, maybe less will be applicable or maybe more will be applicable. Then you have to dispose it from different place to different place. You have to idea about the specific weight of that compaction also. But if you represent the solid waste quantity in the tons, then it is very simple. This much amount of waste is there, this much ton of waste is there, then we can dispose this much of ton of waste directly to the without knowing its degree of compaction also. That's why the representation of waste quantity in tons is much better than this volume measurement in the degree of compaction or the specific weight of the waste. Now, this is the weight record are necessary for the transport of solid waste because highway weight limit restrict the quantity that can be hauled rather than the volume. So that's why this weight record are necessary, because sometimes on the highway they are not allowing and they will becoming restrict on the more weighted vehicles, so the quantity that can be hauled rather than the volume. And this is the data showing weight measurement of MSW quantification in India. This data is about the waste quantification in India, that is they are showing in the year 2004 and 5, 2010 and 11. So MSW, this will represent the ton. Total MSW generation of India in the year 1011 increased by 21% from the year 2000. So from the year 2000, this the weight has been increased more than up to 21%. So this will be a reflection of the weight measurement of the mm, MSW generated in a normal city, and the weight record are necessary for the transport of solid waste because highway people will restrict the quantity that can be hauled rather than the volume. Means they will restrict the quantity on rather than the volume of the solid MSW generation. Now comes to the next. This is the state-wise MS generation data. This is the state-wise MSW generation data. In every state, you can see that this will represent the tons per day. How much tons per day the every state is producing the solid waste generation, and you can see this will be Maharashtra will be more as compared to other state, and Rajasthan is very less. This is the waste generation, total waste generation, not like recyclable, like organic waste or which type of waste. It is for the total waste generation from a city of every state in India, and the highest is the Maharashtra. You can see. Now the which methods are generally used for this waste quantification. So waste quantities are usually estimated on the basis of data gathered by conducting a waste characterization study using previous waste generation data or some combination of the two approaches. So basically, methods commonly used to access solid waste quantity are like, first one is the load count analysis and the weight volume analysis. So this type of platforms are used to know the weight of volume of each truck. So this is the load count analysis and the weight volume analysis. Two type of methods that is being generally used for the waste quantification. So this picture, you can see that platform scales are there. This is the platform scale. This has been used to weight the volume of each truck, and the load count analysis and weight volume analysis. Now comes to the next point. This will be the, what is this load count analysis? In this load count analysis, the number of individual load and the corresponding weight characteristics like type of waste, estimated volume are noted over the specified time period, or during a specific time period. The number of individual loads and the corresponding waste like the type of waste or estimated volume are noted over some specific time period, and the unit generation rates are determined by using the field data where necessary and published data. And like that, in the weight volume analysis, what they are doing, they will do the collection vehicles are weighted at entrance to transfer station using platform scales, and the volume of each truck is estimated. So this is about the weight volume analysis. Collection vehicles are weighted at entrance to transfer station using platform scale. You can see in the picture, last picture, this type of platform scale is there. On this platform scale, weighted trucks are there, and this truck will be, and then the volume of each truck is estimated. Then collection vehicle are weighted at entrance to transfer station using platform scale. It should be a platform scale should be used, and they will going to estimate the total volume of the truck. So though, as we know, two type of methods has been used for the estimation of solid waste. First is the load count analysis, next is the weight volume analysis. Now next is also a different analysis is there, that is material mass balance analysis. In this material mass balance analysis, what we'll do, the only way to determine the generation of movement of solid waste with any degree of reliability is to perform a detailed material balance analysis for each generation source, such as an individual home or commercial or like on an industrial activity. So in this, what happened in this material mass balance, first is the stored material is there. You can see this is the stored material like raw material, products, solid waste, all those things. So accumulation, this it will work on this formula. Accumulation is equal to inflow minus outflow plus generation. So inflow will be given to this waste, this total amount, then a stored material, and then outflow will come. This is the product, and this outflow is the solid waste, and the solid waste or solids in wastewater, and the outflow is the combustion of the combustion gases and the acids. So the accumulation we can calculate is equal to inflow minus outflow. Inflow is this area, this amount, and then minus outflow. Outflow this one plus generation, this one. So all these are outflow and this is the inflow. And this formula can be used to calculate the material mass balance analysis. It is the only way to determine the generation and movement of solid waste with any degree of reliability, and it is used to perform a detailed material balance analysis for each generation source, such as like individual home or commercial or any industrial activity. In this way, the material mass balance analysis will work, and it will determine the generation and movement of solid waste with any degree of reliability, and it is going to perform a detailed material balance analysis. It will give you idea about the detailed material balance analysis. Material balance analysis. And for each generation source, such as individual homes or for any commercial area or any industrial activity. So this mass balance analysis will work in a landfill. So how it will work? Like it is an example of mass balance of methane CH4 gas from landfill. Waste placed is equal to mass leaving through the leachate. Means waste is placed in an on a landfill, and then how much amount of mass is leaving through the leachate plus mass leaving through landfill gases and plus waste remaining plus mass transformed to other product. So this is an example of mass balance of methane gas from a landfill. You can see that this is a picturization of a landfill like this. Anaerobic methane production is there, and this is the lateral migration. Directly this methane production they can take from this place only. This is the methane storage, gas well is there, and the CH4 emission everywhere it is there. Aerobic, this is will reflect the aerobic methane oxidation, methanotropes in the cover soil, and this type of reaction is going on. Oxygen is there, first aerobic reaction takes place. Aerobic reaction means in the presence of oxygen some reaction will occur, that is methane and carbon dioxide will produce, and then landfill gases anaerobic condition will occur. So this is an example of mass balance in a landfill. This is an example of mass balance in landfill. First of all is the waste placed, means where we are placing the waste. If we place the waste, then the amount they have displaced means the mass that is leaving through the leachate. Mass leaving through the leachate means the place that is leaving through the leachate, and then mass leaving through landfill gas. Also, next point is the landfill gas. The mass is the mass that will be leaving through the landfill gas. Next is the waste that is remaining in that particular area, and then mass transferred to other product. Mass transformed to other product. So this you can see that this is an example of this mass balance of this methane. So we are studying this waste quantification to know total amount of waste if we will place in a landfill, then how this methane will be generated and which type of this reaction will occur on the landfill sites. So this will be give you idea about this mass balance in a landfill. So waste quantification will leads you toward the mass balance of landfill. Mass balance, and mass balance can work anywhere. as I have discussed, like either on a in a industrial way, or in a household waste, or in a residential waste, anyway. So we are applying this mass balance to here in a landfill. So for a particular city, this type of calculation has been done to know how much amount of methane we can obtain from this particular solid waste, from that particular landfill site. So this will be acting towards the recovery of waste to energy recovery. As from waste, this energy recovery is the methane or carbon dioxide, and this can be used for some electricity purpose or any other purpose. So the first is about like this, for this mass balance is like waste we are placing into the landfill site, and then mass leaving through the leachate, means the leachate, how much mass that will be captured by the leachate, plus mass leaving through landfill gas, means how much space can be there that has been leaving through the landfill gases, and then how much amount of waste should be remaining waste, plus mass transferred to other products, how much amount of waste has been transformed into the other products, maybe some useful product, maybe some humus, maybe some manure is there. So this will be only we will get idea after this waste compaction. So I have discussed in this lecture, I have discussed about the waste quantification. Waste quantification is very important to know the characteristics of a waste that is generated from any area. And for this lecture, these are the some references of the some textbook which you can follow to know details about this study. And thank you for today's lecture, and I'm going to conclude this lecture like that. I have discussed you about the waste quantification. Waste quantification is very much important to know how much amount of recyclable percentage of the waste is there in the total solid waste, and the total amount, the waste compaction by two methods is there. First is the specific weight method, and second is the total amount of the waste. So if we will calculate waste on the basis of tons only, then this will be more comfortable. And two type of mass balance, I have also discussed about the mass balance, and I have explained it with the example of a landfill. And next point is that two type of load count method is there. Two type of method is there to calculate the total waste quantification of the solid waste. So next lecture I'll discuss about the some treatment method for this solid waste. So thank you for today's lecture, and if you have any query or any doubt regarding this lecture, you can write in the comment box, or you can directly mail me to my given mail id, that is shikha.pandy@gmail.com. So this lecture is about the quantification of waste management. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.